Welcome to part one of case study EX2, where we'll describe how to apply key operators we've been discussing from RxJava's Observable class. Part one of this case study explores how to use many of the RxJava operators to create large, random big integer objects and asynchronously check to see if they're prime using a new background thread. As always, you can find the source code we'll be covering here in a moment at the link at the bottom of this slide. We're now in my IntelliJ project for case study EX2. Let's start by taking a look at the Ex2 class itself, which provides the main entry point into the test program. As you can see, there are two methods under test here. The first is called testIsPrimeTimed, and this is used to test a stream of random big integers to determine which values are prime using an asynchronous, time-driven observable stream. That's the method we'll be focusing on in this part one of the videos. There's also another method called testIsPrimeAsync, and I'll talk more about that in the second video in this series. Once both these methods are registered with the async task barrier, we then go ahead and run all the tasks. They will go and do a bunch of asynchronous processing in the background, and the main thread will call blocking get to wait for the computations to finish, at which point we'll print out how many tests ran successfully. So now let's go ahead and take a look at the observable ex file. This is where the interesting things get done. We start by defining a few fields. We have something called smax value, which is the largest random number that we're going to generate here. We also have another field that's used to determine the maximum number of iterations we're going to run. And then we also have a field called sLowerBound, and that's used to be the starting point for the randomly generated numbers. And we intentionally subtract smax iterations from smax value in order to ensure we have a bunch of duplicates, because we're going to be testing out a cool memoization technique here. I'll talk more about that in a second. We also have another field called sRandom, which is a random number generator. We have a map, which is a prime cache, and this is what's called a memoizer cache. If you Google memoizing, you'll see what memoizers are. They're basically caches. They're going to be used to map candidate prime numbers to their smallest factor if they're not prime, or 0 if they are prime. And we make this a concurrent hash map because we're going to run the computations in multiple threads. We also have ourselves a duration field called sleep duration, which is going to be used to sleep for half a second. We'll use this for the interval-based factory method operator that's part of RxJava. Then we also have yet another field that's a predicate called sOnlyOdd, and you can see what this does is it checks to see whether a big integer is odd or even, and so this will return true if the number is odd. We're going to use that because we want to get rid of things that are even, since they could not possibly be prime. And then down here we have a final field called sGenerateRandomBigInteger, and this is essentially going to take the value of a big integer, and the value will be the lower bound plus the next random number, and up to the smax iterations value, and we'll use this in order to be able to generate a random big integer. And you'll see how that gets used below in some of the test methods. So we're just going to talk about the testIsPrime method first. And as usual, we start by creating a string buffer that's going to keep track of diagnostics. We're going to print out when we're all done. We then go ahead and create ourselves a consumer that we use as a callback with the action operator, doOnNext, in order to write a given big integer to the string buffer. So you can see it just goes ahead and essentially prints it to the string buffer. And then down here, we have our main stream. Now, there's an outer stream and an inner stream. The observable that we use here is going to be created using the create factor method operator. And we're going to pass in this, essentially this emitter. We'll talk about that in a second. And it's going to emit random, odd, large, big integers at an interval, basically once every half a second. We'll take a look at that code in a second. Assuming that that's all running and it's going to be running in its own thread, then what we're going to do is in this part of our outermost observable stream, we're going to first log the big integer as a debugging aid. Then we're going to go ahead and take the big integer and check to see if it's prime. And the checkIfPrime method is very clever. As you can see here, what it does is it's going to go ahead and make something called a new prime result. Take a look at that. It's basically a class that we use to make, to hold candidate primes and smallest factors, or an indication if something is in fact prime. And we're going to pass in the prime candidate, and then we're going to go ahead and pass in the result of calling the compute if absent check if act, atomic check if act, or check then act method. And this is something that's defined on concurrent hash map. And what that's going to do is it's going to take the prime candidate, and if there's already a value that's associated with that prime candidate in the hash map, then of course we'll just get that value back. That'll be either the smallest factor or 0 if it's prime. Or if there is no prime candidate, what we're going to do then is we're going to call this mapper function that's passed in here, which is going to actually go out and compute whether or not a number is prime. So in this case, you can see we're going to have a big integer, and we're going to then do a somewhat brute force algorithm to see whether or not a number is a prime number. And this is intentionally meant to be brute force just so we want to slow things down, thereby demonstrating the benefits of the memoizer cache when there's already a value that's associated with a given prime candidate key. So you can look at the code. This is just a very basic way of computing if a number is prime. We then go ahead and we'll output the results that comes back from this, which, as you can see here, will be essentially a prime result, and we'll print that out. And then over here, we're going to call the doOnComplete action operator. And what that's going to do is it's going to have the side effect when everything's done, when the stream is finished being processed, we're going to go ahead and display all the information we've logged in our string buffer. And then the last thing we're going to do here is we're going to call the ignore elements method. This is one of those suppressing operators we talked about before, and that's going to return a completable that will be used to synchronize with the async task barrier framework. So that's kind of the outermost observable stream. Now let's go ahead and kind of duck down in the inner part of this. And this is the emit interval method. And this is essentially a factory method that bridges the reactive world of observables and RxJava with a callback style world to emit a time-based flow of random big integers at a periodic interval in a background thread. So as you can see, we have an emitter that's passed in here. You'll see how that gets used in a moment. And what we're going to do is we're going to use the interval operator that's defined on observable. And that's going to essentially generate values at whatever the duration is. In this case, the duration is every half a second. So every half a second, a value will be generated. And it starts basically at 1, but we ignore the values. We don't care what the values are. We're just using this basically as a pulse timer to pulse out signals. And what we do is we just go ahead and generate a random big integer by using this function we showed earlier, which will just generate the appropriate random big integer that's in the range. And we then go ahead and use the filter suppressing operator to get rid of any random big integers that are even, because there's no sense in checking to see if they're prime or not, of course. And remember, interval will go on forever. It's going to generate events from now till the end of time if we let it run that long. But we don't want it to run that long. We want to use another suppressing operator, which is the take operator, which will ensure that we only take S max iterations of odd big integers. So we only want to generate essentially 10 of them. So at this point, we then use the subscribe terminal operator. And this is where we connect it with the emitter that was passed in as a parameter up here. You can see we have this emitter that's passed in. And what we're going to do here is we're going to say, if everything goes well, just go ahead and send out the next event. That'll be propagated up to the outer stream, the one that was going to be connected to the create factor method operator we looked at first. If something goes wrong, we're just going to say we're done. And when we're done, we're going to say we're done. So we're either going to be emitting events, which will be these random big integers that are odd, or we're going to say we're completed. And of course, all this stuff will be piped through from the create call, which is, again, potentially dynamically sized, even though we limit it to 10 in this case, or S max iterations. And then those values that come out from the background thread will then be handled in the main thread of control. So that's essentially what's going on here. So if we are compiling our program and testing it, you can see something we'll talk about when we get to part 2 of the video. You can see that the test is prime async stuff runs very quickly, and you'll see why when we get to part 2. Here's the output from test is prime timed. And if you look carefully, you can see that we're basically emitting values every half a second. And this is indicating where we're looking up to see whether something's a prime number or not a prime number, and so on and so forth. And so this is basically just showing you the values that are generated. And you can see that in some cases, we've already seen a duplicate. So whenever there's a duplicate, then we're going to go ahead and look that up in the map. So it'll be, look it up in the concurrent hash map, the memoizer cache, if you will. And so that'll be done faster. So we don't actually have to do the checking if we have determined it's already in the map. So that's what a memoizer is there for. You can also see that everything here is running in a RX computation thread pool -1 thread. That's the one that's running the interval, which is the computation thread. And so part of the computation pool. So there's only one thread involved here. So keep that in mind, again, when we talk about part 2, where we look at the async variant of this particular test program.